Hi fellas, this is Chemaddcts again to the solution. Welcome back to another video tutorial. Well fellas, now we're gonna solve this question. Okay, so let's start. Okay, so the question says the diagram below shows the pattern in the first ionization energies of the first 18 elements. Oh, okay, okay, so in here the diagram below shows the pattern in the first ionization energies of the first 18 elements. Okay, so as from the diagram we can see that this this is the trend along trend in ionization energy along period. So if we recall, we can see that this is the trend in ionization energy along period. Okay. So this is the trend in ionization energy along the period. Okay. So here this is the ionization energy on the y-axis, and on the x-axis this is the atomic number. So by this thing we can be sure that this is the trend in ionization energy along the period. So this is the typical graph for trend in ionization energy along period. Okay, this is along the period, not down the group. Okay, now let us solve the first question. Given the equation including state symbols for the first ionization energy of fluorine, so we need to write the equation for the first ionization energy of fluorine. So let us first recall what is meant by first ionization energy. Okay, let's have a glance of first ionization energy. So it is the energy required the energy required for energy required to remove one electron, okay, from each of 1 mole of gaseous atoms. So it is the energy required to remove one electron from each of 1 mole of gaseous atoms. Okay, so in here they have asked us to find the equation for first ionization energy of fluorine. So tell us, we know that fluorine exists as F2 diatomic molecule in the nature. Fluorine exists as diatomic molecules in nature. So it will have 2 fluorine atoms. So in the gaseous state, when we atomized these fluorine molecules, we will get 2 fluorine atoms. So we are now ionizing 2 fluorine atoms. Since if we want to ionize this fluorine, so at first we need to break this down into atoms. So here it is in molecule form. Now we are going to break this down into atoms. So if we break this molecule into atoms, then we will get individual 2 individual atoms. Okay, so these exist as in gaseous atoms. So this would be in gaseous atoms. Then by removing electron, we will get 2 fluoride F plus positive fluoride uh, ion plus 2 electrons. Since 2 atoms are being ionized here, so 2 electrons will be given. Okay, forming 2 positively charged fluoride ion. Okay, so that is how we're gonna write the answer, write the equation. Okay. So in here we can see that there are 2 marks for this question. So 1 mark for mentioning the species there. For this species, for mentioning this species, we will get 1 mark, and for uh, mentioning the state symbols are really necessary in this case. Okay, since they have said in the question that including state symbols, so we need to mention the state symbols, okay, for each species. So this is how we gonna solve A. Now let's have a look on B. Okay, let's see what does B asked. Explain why there is a general increase in the first ionization energy from sodium to argon. From before, as before, we have said that this is the trend in ionization energy along the period. So since this is the trend in ionization energy along the period, so we need to discuss according to the period, the trend in ionization energy along the period. Okay. So if we move along the period, if we move along the period, okay, so let's see what happens. Okay, so if we move along the periods, the atoms tends to become smaller. Okay, the atoms atoms get smaller in size. Okay, size. So atoms get smaller in size. So let's see how. If we move along the period, number of electrons and the the size of electrons, or the number of electrons and the size of nucleus increases. So there is increase in attraction between the outer electrons and the nucleus. Okay, so this is the outer electron and this is the nucleus. So there is an increase in size. So increase in attraction. There is an increase in attraction between this outer electron and this nucleus. Okay. So since the number of electrons increases along the period, as well as the nuclear charge increases, so there is a increase in attraction between the valence electrons and the nucleus. And there is also one thing, one factor is that as we go along the period, the shielding remains the same. The fulfilled number of fulfilled shells, inner shells, remains the same. Okay, so if you have noticed, the number of inner shells remains the same. Okay, so along the period 2, the number of inner shell is what 2, sorry, number of inner shells is 1, I guess. So there is let us see, this is period 1, 2, 3. Yeah, so number of inner shells remains same. So along the period, suppose take period 3 for instance. So for period 3 there are total 3 shells. So 2 would be the inner shells. So as we go along the period 3, okay, so in here as we go along the period 3, this should be this period 3, it starts sodium to sodium to argon. Yeah, this is period 3. So this is the period 3. Okay. So as we move along sodium to argon, this is the period 3. So you will notice that we will notice that total number of shells is 3. Okay, no matter what, the total number of shells is 3. So there would be 2 inner shells and 1 outer shells. So total number of electrons in the inner shell is constant, it won't change. Okay, the only change that will happen in the valence shell, so the only change will be the number of electrons in the outer shell. Okay, so the total number of electrons in the inner shell remains same, and the total number of inner shells or shielding, that we can say, remains the same. So this results in increase in attraction between the valence electrons. This results increase in attraction between uh, valence electrons and nucleus. Okay, so this results in increase in attraction between the valence electrons and nucleus, since shielding is same. Is same. Okay, since the shielding is same, the increase in attraction between the valence electrons and nucleus increases. Increase in attraction between valence electrons and nucleus. Okay, so this results atoms to get smaller in size. So there is another point that we have known, that we have came to know. So that is shielding is same. So the atoms get smaller in size because shielding is same, shielding remains same. Okay, shielding is constant. Anything, shielding is same, shielding remains same. Then another point is nuclear. Here the nuclear charge also increases as we move along the period. Okay, so as we move along the period, the nuclear charge increases. The nuclear charge increases. Then what? Uh, this results there is stronger attraction between the nucleus and outer electrons. So this results the stronger attraction between the nucleus and outer electrons. Okay, so there is stronger attraction between nucleus, inner nucleus, and outer shell electrons or valence electrons, you can say. Okay, so since these 2 points are same, so for mentioning these two things you will gain 1 mark, and for mentioning this thing, this will be treated as individual point, so for this you will gain 1 mark. And for mentioning this thing, this fourth point, you will gain 1 mark. So the total mark for this question is 3. Okay, so the examiner has treated these 2 points as one, since this literally means the same thing. Always remember that uh, size and shielding almost remains the size and shielding treated the same. So it is wise to mention atomic size, to talk about atomic size and shielding separately. So this will be this this would provide this would provide proper security to gain marks. Okay, so that is how we're gonna do. So if we move along the period, we can see that atoms get smaller in size, shielding remains the same, nuclear charge increases, there is strong attraction between nucleus and outer shell electrons. Okay? So that is why the there is generally increase in the first ionization energies from sodium to argon. So later on we will discuss the dip here, dip in the why there are dips in this graph. On the next tutorial we're gonna discuss why there are some dips in the graph. Okay, so until then, stay cool, stay awesome, best of luck for your exam, and as always, peace with chemistry.